Hello students, let us have a brief idea, and this is part of the revision series of the JEE Main 2024. Horizontal projectile motion. Horizontal projectile motion, if you observe, an particle is thrown horizontal with velocity u, and here initially vertical velocity is 0. If you observe, the acceleration is acting only downward, that is g, and horizontal acceleration is 0. And if you observe any arbitrary point P at a distance x comma y at a time t, and here the velocity at that time will be v, it is making an angle beta with the x axis, and I can resolve that vector into two components vx and vy. So this is basic idea regarding horizontal projectile. So whenever you get horizontal projectile in mind, and most important topic is trajectory, equation of trajectory. For finding out equation of trajectory, if you forget about the formula, about the shortcut technique, just to keep in mind, the strategy here is first to find horizontal displacement as uxt plus of axt square, and then find vertical displacement as uyt plus of ayt square. Just by eliminating from these two, just eliminate t should be eliminated, and after that you must express y as the function of x. So this is horizontal projectile trajectory. Not only horizontal projectile, even in case of oblique projectile also, the strategy for the equation of trajectory is same. Express horizontal displacement and express vertical displacement, eliminate time from those two equations, and finally express y in terms of the x. That is equation of trajectory. Now, here the initial assumptions are: initial velocity is u, initial velocity along y direction is 0, initial acceleration along y direction is g, so this is actually ay. And one more thing, there is no acceleration along horizontal, so horizontal acceleration equal to 0. And by keeping this in mind, now let us try to solve the things for equation of trajectory. So consider a point P x comma y at any time t as shown here. Now horizontal motion. Horizontal motion, let me give you an idea. Since acceleration due to this one, gravity is acting downward and there is no acceleration along the horizontal, so ax is 0. And when ax is 0, I can represent the displacement along the x-axis as uxt plus of axt square, and ax is 0, so I can write x is equal to uxt. And from this, I can write ux is actually given as u only directly, so I can write x is equal to ut. Now, the same diagram, once again you have an idea. So, whatever the expression we got in the previous screen, that is x equal to ut. And from this I can write t equal to x by u. Now, along vertical direction, the vertical displacement can be written as ay is g and uy is 0, s is equal to uyt plus half ayt square, and by substituting these things here, as uy is 0, so this expression will be 0 directly, and I am left with y is equal to half gt square, and by substituting this x value here, I can get y equal to half g, t is x by u, so by substituting that value I can get here y is equal to g by 2u square times x square. As it is as similar to the parabolic equation, y is equal to kx square. This is parabolic equation, so it represents parabolic path. Now, I hope you got an idea about this trajectory of horizontal projectile. Now, coming to the next thing, velocity at any instant. And in kinematics, I hope you remember, velocity at any instant, we must get in our mind direct formula, v equal to u plus at, simple idea. First equation of motion can give us an idea. Now, by considering that horizontal, let us see first. Horizontally, Vx is equal to ux plus axt. As ax is 0, so term will be neglected here. Now Vx will be u only. Now coming to the vertical, Vy is equal to uy plus ayt. Here uy is 0. As uy is 0, I will get vy equal to gt. So finally, the expression for velocity along x-axis is u, velocity along y-axis is gt. So by combining these two for the velocity vector at any time can be expressed like this: vx in I direction plus vy in j direction. And vx is same as initial u and vy is gt. So I can write this one like this: u in I direction plus gt in j direction. And magnitude of the velocity can be taken by simple vector magnitude method, square root of I coefficient square plus j coefficient square, that is square root of u square plus g square t square. Now the direction of the velocity also can be find out easily from the vector method. Tan theta, suppose if it is making beta with the x-axis, tan beta equal to j coefficient by I coefficient, that is gt by u. So this is about the velocity at any instant. Now coming to the height and range. Height is nothing but, suppose a projectile is thrown horizontally. Let me give you a basic idea. Suppose it reaches, after throwing with velocity u from certain height, let us say certain height, let us assume this is the ground, okay, and it is reaching the ground, let us assume here, at a time t is equal to, let us say, capital T. So at t is equal to t, whatever the displacement along vertical direction is your height, whatever the displacement along x direction is your range. Simple idea. So the height is nothing but vertical displacement when t is equal to capital T is h, and range is horizontal displacement when t is equal to capital T. So these are the two ideas behind this one. So now I hope you can understand. So by simply basic equations of motion we can get this one. So for coming to the approach here, y equal to ut plus half at square and y equal to uyt, uy is 0. So now I can write here y equal to uyt plus half ayt square, and it can be written as uy is 0 and half gt square. So suppose whenever you get this t value, equal to capital T, then this y is going to be h. So I can write in place of y as h equal to half g, in the place of t I can write capital T. Yes. Now, and from this one, this is the height actually, and from this one I can get the expression for t. So now write the t expression, t equal to square root of 2h by g, and from this I want range. Range is nothing but horizontal displacement. X is equal to ut plus half ax t square, and ax is 0, t is capital T, ux is u. So I can write in the place of x r. So now r equal to ut. And what is t value? T value is readily available here. So r equal to u, and t is nothing but from here I can write square root of 2h by g. So this is the idea behind height and range. Now, so we are almost done with the conceptual discussion. Before going for the problem solving approach, last topic, deviation of the initial projectile. Suppose, let me assume initially the object is thrown horizontally, right? But because of the acceleration due to gravity downward, it is deviated from its path. How much it is deviated? This distance y, and y is nothing but vertical displacement. So I can write y equal to half gt square. So that deviation is nothing but y, and y can look like half gt square. This is about the deviation suffered by horizontal projectile. Now, suppose I want to solve a numerical based on this. So this is the basic idea. Once you observe the question, a projectile is fired horizontally with a velocity of 98 meters per second from the top of the hill 490 meters high, and the corresponding diagram is available here. What is the data given here? U is given as 98 meters per second, and the question is about find the time taken by the projectile to reach the ground. That means time of flight, capital T, is how much. And the second question, the distance of the target from the hill, that is range. The question here is range. And finally, the velocity with which the projectile hits the ground. So this is the final velocity, how much? So this is V. And V is actually Vx in I direction plus Vy in J direction. And the magnitude of this one can be written as square root of Vx square plus Vy square. And this is at when time equal to capital T. So if you get the first answer, you can get second answer also. R is equal to ut only. And u is given already. What is u value? 98 meters per second is the u. And h is available here. And to find out the t, we want 2h by z. So 2 is given here. From this t will come. From t and u, r will come. Yes. From basic approach, Vx is equal to uxt plus half axt square. Ax is 0. So Vx is equal to ut. I mean u plus at, that is u only. U is given as 98. And Vy is gt. Yes. So the basic approach, and from this question we can understand, if you know the linkage from the given data to the question which is asked, you can answer easily. Let me come to the solution part here. It is given that Ux is equal to 98 meters per second. Now, another information given here is Ax is 0 by default for the horizontal projectile and Uy is 0 by default for the horizontal projectile. And now, the another data which is by default is acceleration along y direction is g, and given data the vertical displacement is 490 meters. At 490 meters, what is y? That is u by t plus half a by t square. By substituting the things, I can get t value here as 10 seconds. And at 10 seconds, the question B, that is sub question B, is what is the horizontal displacement? X is equal to uxt plus half axt square. As ax is 0, ux into t. What is ux given already? 98. 98 into 10, that is 980. And at that time, the same t value 10 seconds. What is the velocity? Velocity along the x direction never change because acceleration 0. So Vx is equal to ux, that is 98. And coming to the vertical velocity, uy plus ay t, and uy is 0. So ay is g, 9.8 into t value is 10. So 98 meter per second. So I will be getting like Vx is 98 and Vy is 98. Both are same 98 only. So by taking the magnitude as 98 root 2, I will be getting the answer. And the angle made by the velocity vector is, as both are the same value, I will be getting 45 degrees. So this is an idea. And please keep in mind, if you get a question on horizontal projectile, it is going to be very easier question. There is no complexity in this one, right? And coming, let me take you people to the second question. This question, if you look at this, it looks complex. But if you think logically, you can solve it dead easily. Once observe this question here. Once observe the question, two particles move in a uniform gravitational field. Uniform gravitational field means acceleration is constant. A in y direction is constant with an acceleration g. At the initial moment, the particles were located at one point. Let me consider that one point is this one. Yes. And from there, moved with velocities u1 3 meter per second and u2 4 meter per second horizontally in opposite directions. So one is moving in this direction, another is moving in this direction. Horizontal projectile. So it is horizontal projectile and this is also horizontal projectile. And if you observe, they both are moving in opposite direction. So let us say this is moving in x direction, minus x axis, and this is moving in plus x axis, let us say. So the question is, find the distance between the 2 points when their velocities are mutually perpendicular to each other. It is really, the question looks complex, but if you think logically, it is going to be very easy. Here the condition, at what time they are becoming perpendicular, we don't know. We need to find out that time first. So find time when V1 is perpendicular to V2. Find. And substitute that time to find out the horizontal displacement x1 and also x2, and this is your answer finally, distance between them, x1 plus x2. Simple idea. And what is the condition from vectors? When the two vectors are perpendicular to each other, the simple idea is dot product is 0. Just use that idea. You take V1, you take V2. Find out V1 and V2. Let us say at the time t. At time t, V1 is, okay, V1 x in I direction plus V1 y in j direction. And V2 x in I direction plus V2 y in j direction. And Vx is equal to, V1 x is equal to U1 by default. And V1 y is equal to GT. Okay, and similarly V2 y also GT. Yes, and V2 x is U2. Simple idea. And from that, by making the dot product, you are going to find out the time t. After getting time t, x1 and x2, you can find out and you can get the answer. This is the solving strategy for this question. Always keep in mind, whenever any question is given, you must think logically and develop a strategy. From the given data, I need to find out the time when V1 and V2 are perpendicular. So V1 dot V2 equal to 0. Find time when they both dot product become 0. And from that, after getting this time, find out x1. After getting this time, find out x2. Then add both of them. That is your answer. That's it. So this is solving strategy for this question. Simple idea. And now the next thing is one labor work. You take VU first to find out what is V1 and what is V2, then do the dot product, and then find time t, and after that find out, obtain x1 and x2, and then add them. That is your answer. Simple. Now let me show you that solution part here. Suppose let the velocities of the particle be at right angles to each other after certain time t. Then we can write V1 equal to U1 plus GT. And here U1 is given already, G value you know already, T we need to find out. And similarly, I can write this U1 as by assuming 3, throws 3 I cap plus GT J cap. And coming to the V2, I can write minus 4I because it is moving in opposite direction of that one. So I can write V2 equal to minus 4I plus GTJ. And from these two, just you can do dot product here. And for velocities to be mutually perpendicular, we can write V1 dot V2 equal to 0. So by substituting those values, I can get here V1 is like 3 I cap plus GT J cap dot minus 4 I cap plus GT J cap. This is actual dot product. And in dot product, we know that I component and I component multiplication. That is 3 into minus 4 minus 2 plus GT into GT also, that is G square T square, and which is must be 0 and something shown here. And after this, just by solving, I am going to do the t equal to square root of 12 by g square, or finally 2 root 3 by g. So I got time t now. And my final discussion here is, what is the distance between them? So the distance between them actually from initial point, distance traveled here and here is the horizontal displacement, let us say x1 and x2. Okay. Now, by finding x1 and x2 and adding them, I am going to get my answer. Now, separation between the two particles can be find out. X is ut because ax is 0. So u1 is u2 t is common. U1 plus u2, that is 3 plus 4 7. So 7 into t is already know 2 root 3 by t. Right. So, I hope you understand. Simple strategy. H. Now, so by this, we have completed discussion about the horizontal projectile motion. Now, my dear students, you utilize the time, and for the worksheet on this horizontal projectile, you just go through the description. In description, we have given the link for the worksheet for this horizontal projectile motion. Now, if you want any video on any particular concept which you need, just give in comment and subscribe, share with as many as students as you need. Right? Thank you all. All the best your JEE Main 2024 as well as for your NEET 2024. Thank you.